The Tronxy X1, currently the cheapest 3D printer available on Gearbest for only $120 US. How well does it print out of the box, and what exactly do you need to do to it to get it to print as good as this? In this box here, I have a Tronxy or Tronxy X1. Full disclosure, this was sent to me for free by Gearbest for review, but you don't have to worry about anything biased. If I hate it, I will definitely say so. If I like it, I'll say so too. So the thing about this printer is it's exceedingly cheap. It's only about $150. And for that price, we're not expecting a world beater. We're expecting a budget printer. How much do we need to do to it to make it worthwhile? I'm going to put it together, do a first print, and then print some of the most popular mods of Thingiverse and other places. Then we'll see how good we can get our prints, and we'll decide from that whether it's worthwhile for the money or whether you should just spend more on a more expensive model. Let's get started. Oh, upside down. Had an awesome start. I opened up the box upside down, everything fell everywhere, but not to worry. Now, there's no written instructions anywhere, but there is a micro USB flash drive. So I'm hoping on here are some instructions and we can start the build. Quick note on materials, there are some metal rails, some extruded parts, and it looks like some things will slide up and down to make the axes move. Apart from that, everything else is laser cut acrylic. The protective paper is still on. I'm actually terrible at peeling off these things. It's going to take me as long as anything else. Let's find these instructions. Success! As expected, there are instructions on the SD card, so let's begin a time lapse and see how quickly we can put this thing together. Like usual, I'm going to have my clock going to see just how long it takes. Now, because I am so bad at peeling off this backing paper, I think I'm going to do that first and reset the clock. Otherwise, it's not going to be a fair indication of how long this build actually takes. Oh, 26 minutes just for that. You know what? Don't buy the thing. Just kidding. All right, let's put it together and see what we can do. I'm gonna start that timer again, however. Done in 2 hours and 51 minutes. Let me change the battery in that light and then I'll tell you my reflections. All right, that's better. So I finished it in a fraction under 3 hours, just over 3 hours if you include peeling off all of the paper off the acrylic pieces. Now, the last printer I assembled was my Mark III i3 kit, and although it took more than twice as long, it was completely different to this. The instructions were very thorough. It was pretty much impossible to go wrong. Now the instructions were pretty average, but for all my criticisms that I'm going to have in this video, you have to remember that this printer is very, very cheap and they've got to save the money somewhere. So part of that is going to come from the acrylic pieces rather than something like metal, like in the Audi 3D printer. And other areas where they're going to save money is in the instructions. So if they don't have a translator or someone paid to put in the hours to develop really good documentation, well, it's not going to be as good as a more expensive printer. There were a couple of pages of the instructions where things were ambiguous. Things like the direction the stepper motors were meant to face. I would complete a step, get to the next page, and then have to go back and rotate it around 90 degrees. All I could see from the current view was that it wasn't facing either this way or this way, but that still left 2 different directions it could have faced, and on a couple of occasions, I unfortunately got it wrong. I did get into the habit of flicking forward later on in the build as I was unsure about things, and sometimes it helped me solve my problems, other times it didn't. Probably the hardest thing on this build was making the wiring tidy. If I spin this around, I think I've done a pretty good job here. You've got to be careful you don't fall into the trap of making all of these really tight, which means when it comes to the top or when it comes out here, all of a sudden it's going to be pulling tight because you haven't allowed enough freedom of movement. So I think I haven't fallen into that trap. I feel like I should cable tie around the stepper motor here and keep this one locked against it. And I match the length to go with the Bowden extruded tube. So hopefully there's enough play in that. Seem to be down one clip. Quite possible I've lost that. Also, I suppose possible that it was never in the kit. Other bits where the instructions were less than ideal was it informed me I needed to put together all of this case before the actual connections are made on the inside. So I realized that fairly early on and I disassembled it the last step that I had done, and I managed to plug everything in and then put together the final pieces. Now looking at the overall design, it's fairly interesting. It's not what you would call rigid, and I think that's going to be the limitation to the design. There's a lot of wobble in here. The Y-axis is actually pretty good. The Z-axis slides pretty well, but there's a lot of wobble overall in the assembly. Doesn't seem to be any play in the Z-axis, which is good for Z banding. If you have any slop in the nut as it tries to turn to go up, the first part of that movement is going to be taken up by the sloppiness, and that means for every Z step it's asking for, it's not getting all of them, and you end up with inaccuracies over the print, and that can appear as banding on the vertical wall. So fingers crossed we don't see that with this printer. Now in Australia, this cord is completely useless. Fortunately, on a recent trip to JCar, I stocked up on the equivalent Australian plug. So let's open up the power brick, turn it on, load up some filament, and we'll see if there's anything ready to print on the SD card. Now, a lot of people would argue that the printer is a lot safer because it comes with a power brick instead of a power supply somewhere. It means you're not handling any mains wiring, and it's pretty hard to argue with that. Here goes nothing. All right, so it has powered on nicely. There's no spinning dial wheel like you see on most other 3D printers, so I have to manually press the buttons here. I've seen on the internet elsewhere that this is pretty annoying, so let's see how I find it. Let's try and home. Two out of three ain't bad. Hopefully we can get the third one sitting nicely. All right, I can already see there was no specific instruction on where the stopper should be for the Z axis. So I'm already way below where I should be. I'm gonna hit the switch manually and then loosen that bolt and slide it up a lot higher. So on the back here is our Z end stop. And there's quite a lot of room to slide it up and down. I suppose that's how you tune the starting height. Okay, just gonna power off for a minute to take away the power from the stepper motors. And that should allow me to twist this up manually and get it into a nicer position. Sometimes you can cheat like this. You can wind it up to where you think it should be and then slide the Z end stop up into place, so it should hit pretty close to there. Going to insert the SD card into the back. I can see it. Oh wow, that is poorly placed. All of the cables going in cover that directly. Maybe this is better to use as a tethered printer. We are preheating for PLA. Tronxy PLA. It's a very small amount, and I've checked and there is one file on the SD card. I do like the extruded design. It feels very rugged and you can see what you're doing, which makes it easy to work out problems and fix them. Okay, I'm gonna go for the manual entry method. Well, that's gonna be impossible because it's touching the bed. This is the Z position fast option from the menu. Not exactly living up to its name. Okay, we do have some extrusion. Let's push through a little bit more. It is coming out. Now I suppose we should try and level the bed. The bed, of course, is not heated on a printer this cheap, so that limits you to PLA. It looks like it's a PCB-like material, so the fiberglass from underneath. I've never printed on something like this before. I do have a sheet of build tack ready to go, so we'll try it with the default one for the test print, and then we will add this if we need to after that. So to level the bed, I'm going to home all, and then I'm going to turn off the power to disable the motors, move it around, and adjust the thumb wheels from there. All right. Put a wipe with IPA to get rid of any fingerprints. And I did find a spare bulldog clip, so all 4 corners are in place. Let's do a test print. All right, print has finished. It looks pretty successful. I had to do some manual live adjusting of the first layer by twisting the thumb screws. I'm going to try and unclip this and see if I can flex it off since it is a flexible material. Oh, that was unexpected. Popped right off. Maybe this is actually quite a good material. I have to say this is not a bad print at all. Not too bad. Let's get this under the close-up camera and then let's print a 3D benchy. Oh dear, well, I did run out of the sample filament and that is my fault, not the machines, but it does highlight another place where they're saving money, and that is on something like a Mark III. It's full of smart sensors. On this, it's plain and simple, but that's okay because it's good for learning about 3D printing. Now the quality of this is not actually too bad. The main complaint that I have about this printer in terms of the print quality is the lack of a fan. PLA generally works better with a fan to cool down the layers, especially on those smaller areas where things can kind of melt. There's also a bit of stringing here, so I'll play with that in the profile for my next print. Speaking of my next print, you might have noticed that there is no spool holder. So there's a couple of designs on Thingiverse I'm going to try. They're going to be a lot bigger and take a lot longer, so we'll see just how well they stick to this base here. I'm going to have to move this elsewhere, I think, in front of this Cocoon printer, so I can use its spool holder to get this next job done. Let's do it. Well, it's finished and it seems to be a success. Let's juggle everything over to the table. Seems to be not too bad. There's a fair amount of stringing in between the pieces. I'll have to further up the retraction settings. Seems to be stuck pretty nicely to this base. Let's go for a flex. I think I better head back to Thingiverse, look at the instructions and put this thing together, and then this thing can sit wherever it needs to because it's going to sit on top. Now I believe the instructions call for using 10mm wooden dowel, but I'm going to use 10mm carbon fiber because I can. So I'm opening up the bit that's meant to hold the Z screw. I think it's a common misconception that the Z screw should be held from either end. That only works if it's perfectly straight. If it's not straight and before it was wobbling on the top, that means if you hold the top, it's going to wobble in the middle, and that's going to move everything side to side, and that's going to introduce Z wobble artifacts. So no go. This stuff is super cheap on eBay, a couple of dollars per meter. Looks pretty good. I think it's time to do our next print. Just decided the next mod should be a fan. As I said earlier with PLA, they'll always work a lot better if you can cool pretty much after the first layer. especially on small parts that are detailed. Without a fan, they tend to just melt together. So should be a quick print. Let's get it going. So this took 3 attempts. The first 2 were complete spaghetti. That's because it came loose on the Garolite build plate. Just another way that they save money. It doesn't have any sophisticated auto bed leveling or anything like that. You need to keep it spot on, and it pays until you got your printer really dialed in to pay attention to the first layer and to do some live tweaks as you go, just to make sure it's okay. So now we need to fit this. I have a 40mm fan ready, and there's a single bolt installation. So there's a bolt on the side of here, and then it is going to bolt to there with the fan in place, and fingers crossed that it works straight away. Just paused my physical installation of the fan, and it is great news. There's one plug left called fan. I have a fan with the correct plug. The wires will need to be extended, but I plugged it in, went to the menu, manually set the fan on, and on it came. So that means everything is in the firmware like we expect, and this is going to be a really easy install. So the fan is fitted. It's a really neat installation. Only 1 bolt to be undone and then put back through the middle of the fan shroud. 4 bolts to put the fan on, and extending the wires, and there's a plug already in there. Nothing to change in the firmware. About as easy as it gets. I've tweaked the slicer settings a little bit more to try and minimize the stringing. I've loaded up some awesome fluoro green, which is a sample from X3D. And we're ready to print another follow-up benchy. So it took 2 goes, but I did get a really nice benchy. As you can see from the close-up, I have tweaked my slicer profile, and I've eliminated practically all of the stringing. The cooling fan has tidied up the outer extrusions as well. Overall, I would say this is pretty damn impressive for such a cheap machine. Just to prove that it wasn't a fluke, I loaded up this, a baby Groot. And just to make it even harder, I scaled it down and printed it without support. Now, the detail on this is pretty damn amazing, I would say, considering the price of the printer. Lower arm has shifted about 1 millimeter to the side, and those fingers have some minor imperfections, but you got to remember they're about 1.5 millimeters wide, so these things are tiny. How nice is that gold filament from X3D? So I guess it's time to wrap this up. Let's look at the pros and the cons of this printer. We'll start with the negatives, and firstly, the assembly. It really wasn't too bad, but the instructions could be improved. For the price of the printer, they're probably pretty reasonable, but don't expect everything to be crystal clear and beyond ambiguity. Probably one of the biggest weaknesses is this control box. I don't really like the way that it's separate and the wires have to go in between, and the worst thing of all is the access to the SD card, which is underneath at the back where the wires are. Now, there are a couple of ways around this. Firstly, and this would be my main recommendation, is to use the supplied USB cable and to run this tethered to a laptop. Then you're not stuffing around with a tiny little micro SD going in and out. The second option is a more creative one, but also a more patient approach, and that is to print one of the bases. There's about 3 or 4 available on Gearbest. They move all the electronics underneath the printer, lifting it up. I have to say it looks pretty cool, and I might end up doing that to this one. Still on the control box, the menu system is a little bit clunky. It's a little bit different in the fact it doesn't have a circular encoder wheel. Instead, you have to have buttons for everything, and the buttons just a little bit spongy and don't respond as well as you would like. Probably the final downsides are the basic spec that the printer comes with. It doesn't have a spool holder, it doesn't have a cooling fan, it's pretty much bare minimum. Onto the positives. Firstly, and overwhelmingly, is the price. This is $120 at the time of making this video. That is just so incredibly cheap. It did print pretty reasonably out of the box, and the mods that I've used here to improve it are pretty minimal in cost. Let me go over those. Firstly, we have the spool holder on top. You could always mount yours to something different, but I like everything to be integrated. Secondly, we have the cooling fan over here. Fan's probably going to cost you $5 to $10 for just a 12 volt 40mm one, and it was very easy to wire up. You might have noticed in my final prints I added the sheet of build tack. The Garolite on there did work pretty well, but it's a little bit fussy for being perfectly level. So this build tack is probably going to cost you $10 to $15 for a sheet to trim down and stick on. Remembering that if you always wanted to print on the original surface, just take off the clips, spin it upside down, and it's still there preserved for you. So the next positive is, again, the print quality, but this time not out of the box, but with these modifications. These prints are really quite outstanding considering the price of the printer. No, they're not perfect, and I'm not suggesting that they're going to stack up to something like a Mark III, which costs 5 or 6 times the price, but that costs so much more than this, so you have to keep everything in perspective. Another definite plus for this printer is how moddable they are. There's heaps of files on Thingiverse to do all sorts of things, from stiffening up the frame to extending the print surface. You name it, it's probably going to be there. The parts that you can print on this are going to be dimensionally accurate, which means your mods will be reliable, and every time you fit one, you will improve your print quality. One other nice thing about the printer is their suggested software, and that is Repetier Host. Now this is actually software I used for years and years with my Solidoodle 2 Pro. It has Slicer inbuilt, and I did find a profile online, but the settings were a little bit off. As you would have noticed in this video, every time I printed, I got the settings a little bit better, eventually eliminating all of the stringing. You can get my final Slicer profile in the description for free, as well as a link to the Repetier Host software. So, final thoughts. No, it's not perfect, but it is incredibly cheap. The question you need to ask yourself is, for some of the things that are a little bit annoying on this, can you forgive them for how cheap the price is? And I would say for $120 US, absolutely. The quality that I'm getting out of this printer after just a few basic mods is very encouraging, and it's nice to know that there's even more mods on Thingiverse that you can tweak and tinker and go from there. Can you buy this thing and not mod it and have half decent prints? I would say yes, but the simple mods I've done in this video are inexpensive, and therefore I would highly recommend them. Given the fact that it doesn't have a heated bed, which reduces burn hazards, and it also has an enclosed power brick, which eliminates any dodgy mains wiring, I'd say this is a pretty ideal cheap printer to start a makerspace or for an enthusiast looking to get into 3D printing. This particular model is going to be donated to a local primary school. They're really excited to be getting it, and no doubt they're going to have a great time learning about the wonderful world of 3D printing. If you want to get one, there's a link in the description below. But that's it for now, so thanks for watching, and until next time, happy 3D printing. G'day, it's Michael again. If you like the video, then please click like. If you want to see more content like this in future, click subscribe, and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.